Okay, for next question, that is question number 22, part A. We are given that f of x is equal to function is x square when the value of x is greater than equal to 1 and x when x is less than 1. We have to show that it's not differentiable at x is equal to 1. So if it's not differentiable at x is equal to 1, that means left hand derivative should not be equal to right hand derivative. So let's find out the left hand derivative first. So left hand derivative, and we are doing this at x is equal to 1. So this is given by 1 negative, and this is f of x minus f of 1 a, that is a. We will write it later on. This is f of a upon x minus a. So this becomes limit x tends to 1 negative. Now for value x is less than 1, the value of the function is x. So this becomes f of x is x. So x minus f of a. So f of a is 1. So f of x is equal to x is the function, and f of x becomes x, so f of a. So a is 1, so f of 1 is 1, so this is 1 upon x minus 1, so this goes cancel. And we finally have the left hand derivative is x tends to 1 negative, taking the limit gives me 1. So left hand derivative is equal to 1. Okay, now let's find out the right hand derivative. So to find out the right hand derivative, so right hand derivative at x is equal to 1 will be given as x is greater than a plus. So a is 1, so 1 plus, and the value will remain f of x minus f of a upon x minus a. Okay, for x is greater than 1, the value of the function is x squared. So this is limit x tends to 1 plus this is x squared minus f of a, which is f of 1. So f of 1 is 1 upon x minus 1. Okay. Yeah. So to make you understand better, I can write it as this is limit x tends to 1 plus this is f of x minus f of 1 upon x minus 1. So this becomes limit x tends to 1 plus f of x is x squared, f of 1 is 1, this is x minus 1, and we can, this is a minus b into a plus b upon a minus b. This becomes, so this is now equal to limit x tends to 1 plus, and we are left with x plus 1. And if we take the limit, this becomes 1 plus 1 is equal to 2. So right hand derivative is 2, or we can also try this by taking it to limit h. So let's say x is equal to a small value h greater in h. So x is equal to small value h greater in 1. So as x tends to 1, h tends to 0, which gives limit h tends to 0. So x is 1 plus h plus h. Now I can put the value of h as 1. So h as 0. So 1 plus 0 plus 1 gives me 2. So clearly left hand derivative, right hand derivative is 2 and left hand derivative is 1. So that means the left hand derivative is not equal to left hand derivative is not equal to right hand derivative. So that means that the function is not, this function is not differentiable at x is equal to 1. So the function is not differentiable at x is equal to 1. Moving on to part 2.